Since humanity first looked up at the sparkling night sky, the universe has become a mysterious, fascinating, and challenging realm. The distant stars, mysterious planets, and endless void out there always raise the great questions. Who are we? And where are we in that vast, mysterious picture? It is these mysteries that have ignited a fierce desire in the human heart to overcome all limits and seek answers in the vast universe out there. This is humanity's greatest but also most challenging adventure. Overcoming everything, humanity still began the journey into space, taking the smallest steps to create giant leaps. We accept the direct confrontation with our own limits, proving our enduring will, courage, and endless dreams. And to this day, that journey has never stopped. So, when did humans ignite this risky journey? Besides facing challenges, what achievements have we reaped? Let's look back at this glorious adventure of humanity in today's video. From Earth to the stars, humanity's journey reaching into space. Ever since human civilizations were formed, people have had unique ways of exploring and understanding the universe. At a time when tools were primitive and we had no telescopes, understanding the stars and the universe relied entirely on naked eye observation. Back then, humans mainly observed the movements of celestial bodies like the sun, moon, and stars. From there, the laws of motion were born. Most typically, the alternation of day and night, the changing seasons, and the phases of the moon. Civilizations such as Egypt, Mesopotamia, India, and China began observing and recording astronomical phenomena. They created calendar systems to determine seasons for agriculture and other daily life activities. Phenomena like solar and lunar eclipses were carefully recorded, clearly showing humanity's limitless curiosity about the cosmos. To gain that preliminary understanding, the ancients spent many generations observing the sky and recording the changes of celestial bodies. Most prominent are the achievements of ancient Babylonian astronomers from 4,000 years ago. They possessed vast knowledge of the universe and even had the ability to predict natural phenomena. In addition, ancient people used simple tools like altitude measuring sticks or wooden rings to determine the positions of celestial bodies in the sky. They could identify constellations, thereby creating myths and stories related to the stars they saw. Identifying and classifying constellations not only helped them navigate, but also aided in predicting weather and seasons. Most notably, the astronomical knowledge gathered by the ancients through naked eye observation became the foundation for the development of a scientific system. The cosmological model of ancient Greek civilization. It was synthesized, formed, and developed by philosophers and astronomers, simultaneously serving as a premise for humanity's future understanding. In the 4th century BC, Eudoxus developed the idea that the stars were fixed in the sky and revolved in a spherical orbit every 24 hours. Meanwhile, planets like the sun and moon moved in the space between Earth and the stars. This model was further developed in subsequent centuries, peaking in the 2nd century with Ptolemy's perfected system. He believed that perfect motion must be circular. Therefore, stars and planets all moved in circular orbits. However, to explain the complex periodic motion of the planets, Ptolemy suggested that each planet moved in a fixed circle around a stationary Earth. This is the geocentric theory, dating back to Aristotle in the 4th century BC, asserting that Earth is at the center and stationary. Additionally, some philosophers proposed theories of a heliocentric model, where the sun was considered the center of the universe. Aristarchus of Samos was one of the first to propose this model, marking a distinction in the astronomical science of that time. However, this view was not widely accepted in antiquity because, observing with the naked eye, we only see the sun, moon, and stars revolving around Earth. It must be said that ancient Greek cosmology reflected the development of human thought regarding the universe and our place within it. Despite many limitations, their theories and discoveries laid the foundation for later understandings of astronomy and science. The combination of observation, knowledge, and belief created a valuable legacy, helping humanity continue to explore and understand the vast universe. Not only that, based on astronomical knowledge, humanity invented calendars straight from ancient times. They realized that the cycles of the sun, moon, and stars are repetitive, leading to the division of time into units like days, months, and years. A day was determined by the Earth's rotation on its axis, from sunrise to sunset. A month was typically based on the lunar cycle, specifically the time between two full moons, about 29.5 days. And a year was determined by the time it takes the Earth to orbit the sun, approximately 365 days. Different civilizations had their own calendars and calculation methods, but the most famous are the calendars of the Maya and the Babylonians. First, the ancient Maya calendar is one of the most complex and accurate historical systems developed by the ancient Maya in the Americas. It consisted of three main types: the Hub calendar, the Tzolk'in calendar, and the long count cycle. Each calendar had its own purpose and counting method, but all were interconnected within the Mayan timekeeping system. They did not operate independently, but were bound together in a complex cycle. Every 52 Hub years, or 73 Tzolk'in cycles, both calendars would complete a cycle and start over. This is the calendar round, a crucial time period in the lives of the Maya. Besides this, the Babylonians relied on the moon's cycle to create a lunar calendar, with a month counted from one new moon to the next, which is about 29.5 days. The Babylonian lunar year consisted of 12 months, totaling about 354 days, shorter than the 365-day solar year. This led to a discrepancy of about 11 days per year between the lunar calendar and the solar cycle. To adjust this discrepancy and align their calendar with the seasons, the Babylonians added an intercalary month. Pioneering ancient Babylonian astronomers observed astronomical cycles and discovered many fascinating phenomena and stars, particularly Venus. This discovery not only helped them create an accurate calendar, but also set the stage for much astronomical and calendrical knowledge in other civilizations. The astronomical knowledge and achievements of ancient people were often passed down and used for a long time due to their accuracy in daily life. By the Renaissance, many space researchers became skeptical of the true shape of the planets. When observing with the naked eye, we could only distinguish the sun and the moon. The remaining stars seemed like mere specks of light in the sky. To better understand the universe, humanity needed a special tool to observe the planets: the telescope. In 1608, a Dutch spectacle maker named Hans Lippershey was the first to file a patent for a device that could magnify the size of distant objects. It was extremely compact and handheld, consisting of a convex lens at the front and a concave lens at the back. Thanks to this, users could magnify images of distant objects for easier observation. However, due to its simple construction, images observed through Lippershey's glass were inverted. Furthermore, the magnification was only 3x to 4x, not strong enough for humans to observe the planets and stars in the sky. Additionally, the image wasn't very clear, so celestial bodies couldn't be observed in detail. But it marked a major step in the development of remote observation devices and inspired scientists to improve telescopes for exploring the universe. Also during this period, everything changed. A massive turning point in the journey to explore the vast universe occurred. The notions of Ptolemy's geocentric cosmic system were no longer accurate. European astronomers held different views about the universe and the planets, one of whom was Nicolaus Copernicus. He was one of the most important figures of the Renaissance. His research not only fundamentally changed human understanding of the universe, but also laid the foundation for the scientific revolution, setting the groundwork for modern scientific disciplines. The heliocentric theory. In ancient times, this theory had been proposed but did not receive much support. But after many years of study, Copernicus agreed with the notion that the Sun is the center of the universe, and Earth and other planets revolve around it in circular orbits. Besides this, he introduced additional concepts that were described with much higher accuracy and simplicity. According to him, the Sun held the central, fixed role and did not revolve around any other celestial body. The phenomenon of day and night was due to the Earth's rotation on its own axis, not the entire universe moving around the Earth. The planets in the solar system all orbit the Sun in their own paths. Furthermore, Copernicus argued that the planets were at varying distances from the Sun. This helped explain the differences in their apparent speeds of motion. Right before Copernicus's time, calculating planetary positions was incredibly complex and required various calculations to explain their movements. Through the heliocentric model, the astronomer successfully simplified this arduous task. It became the foundation for later scientists, helping humanity describe the universe more accurately. His research transcended astronomy, creating a profound ideological revolution. The heliocentric model challenged the notion that Earth, and consequently humanity, was at the special central position of the universe. This shift pushed humans to reconsider their place in the vast cosmos, influencing philosophy and theology, and challenging the traditional views of the Catholic Church. Additionally, it helped pave the way for rationalism and modern science. There were many who followed up on Copernicus's achievements, continuing to bring humanity closer to knowledge of the immense universe. They shattered outdated concepts about the world and the universe, presenting new studies despite facing much controversy. And yet it moves. Surely you have heard or known of this quote at least once. It was the astronomer Galileo Galilei who asserted this. He is one of the most important figures in the history of the universe and physics. Galileo was the first to apply experimental methods to scientific research, laying the groundwork for modern physics and astronomy. To explore planets and stars, he relied on Lippershey's telescope to build his own upgraded version. Galileo's device could magnify objects up to 20 times, helping him make many crucial astronomical observations. Most notably, he discovered the 4 large moons orbiting Jupiter, and that the moon's surface was not perfectly smooth but full of mountains and craters, contradicting the belief that celestial bodies were flawless. In addition, Galileo observed sunspots, showing that this giant star also underwent many changes. Particularly, the discovery of Venus's phases brought humanity a giant leap forward. During Galileo's time, the Catholic Church and European society still firmly believed in and used Ptolemy's geocentric model. However, Copernicus's later skepticism regarding its accuracy and his proposal of the heliocentric theory sparked a massive controversy alongside the major discovery concerning Venus. One of the most famous stories in space exploration was born when, in 1610, Galileo published The Starry Messenger, recording his astronomical discoveries. This work caused a sensation and attracted the attention of the scientific community as well as the Church. He presented strong evidence supporting the Copernican theory, which the Church considered a provocative act of defying established norms. In 1616, the Church warned Galileo not to teach or defend this theory. Nevertheless, he continued his research and even publicly debated with scientists and clerics who supported the geocentric system. In 1632, Galileo published dialogue concerning the two chief world systems, comparing Copernicus's heliocentric model and Ptolemy's geocentric model. Although the work maintained a neutral tone, its bias towards the heliocentric theory was quite clear. The book sparked a huge wave of controversy and outraged the Church. In 1633, Galileo was summoned by the Church to the Inquisition in Rome to face charges of heresy. At the trial, Galileo was threatened with torture and forced to renounce his views on the heliocentric theory. Under immense pressure from the Inquisition, he had to sign a confession declaring the Copernican theory false and incompatible with the Catholic faith. It was at this moment that Galileo muttered, "And yet it moves." This quote reflected Galileo's affirmation of the scientific truth that Earth continues to revolve around the Sun, regardless of whether the Church acknowledged it. He inspired later scientists like Johannes Kepler and Isaac Newton, who continued to research and develop scientific theories about the universe. Galileo's contributions were not limited to astronomy, but also paved the way for modern science, helping humanity better understand its place in the vast universe. Moving into the 17th and 18th centuries, the tools used for researching stars and planets were vastly improved. Many brilliant scientists created more modern telescopes for themselves. The most prominent example is Isaac Newton, famous not only for the story of the apple falling on his head and discovering gravity, but also as an inventor of the telescope. In 1668, Newton noticed that telescopes of that era always produced blurry and inaccurate images. He sought to improve this issue by researching and replacing the lenses. The scientist used a parabolic mirror as the primary reflective surface instead of a lens. Newton used a concave spherical mirror to focus light from celestial bodies passing through the aperture onto a focal point inside the tube. The device also featured a flat mirror tilted at a 45-degree angle near the focal point to reflect light sideways to where the observer looked through the eyepiece. Lastly, the eyepiece's main function was to magnify the image for clearer viewing. Newton's reflecting telescope made everything observed sharp and free of chromatic aberration, allowing scientists to easily study the planets. Furthermore, production costs were cheaper because mirrors were easier to make and did not require the high purity of large lenses. Newton's invention initiated the era of the reflecting telescope, which would become the standard in modern astronomy. Thanks to it, astronomy turned a new page with deeper explorations of space and the stars. Besides telescope development, by the late 19th century, scientists also researched and learned more about the age and evolution of stars. This was considered a vital step forward, adding new puzzle pieces to the picture of the vast universe. It was the two scientists, Hermann von Helmholtz and Lord Kelvin, who helped humanity achieve this. They discovered that stars begin forming inside giant clouds of gas and dust, known as nebulae. Under the influence of gravity, regions within the gas cloud begin to contract, gradually forming a dense mass of gas while simultaneously creating immense heat and pressure at the core, leading to star formation. When the core temperature and pressure become sufficiently high, nuclear fusion begins, turning hydrogen into helium and releasing energy as light and heat, illuminating the star and making it an official star. In addition, humanity learned more about the Milky Way, the home of Earth, and hundreds of billions of other stars. The great astronomer William Herschel was the first to conduct detailed observations of this massive spiral galaxy. He used his giant telescope to map the distribution of stars in the Milky Way and recognized its shape. Herschel also realized the Milky Way was not a dense star cloud, but contained a vast quantity of dispersed stars. By the late 19th and early 20th centuries, astronomers began realizing that the Milky Way is just one of millions of galaxies in the universe. These discoveries were clarified by the advancement of telescopes and spectroscopy, helping scientists classify galaxies and better understand their formation and structure. During this period, Edwin Hubble discovered that the Milky Way was not the only universe. By observing nebulae, Hubble proved that they were actually entirely separate galaxies. These vital discoveries helped humanity gain a deeper understanding of space and realize our insignificance in the vast universe. And soon after, in the 20th century, humanity made a series of giant strides, stepping fully into the conquest of space. One of the most important inventions of the 20th century was Albert Einstein's general theory of relativity, published in 1915. This theory changed humanity's view of space and time. Instead of treating space and time as separate elements, Einstein described them as a unified whole known as space-time. With general relativity, Einstein provided a cosmological theory where the universe is not static but can expand or contract. This opened up new research questions about the formation and structure of the universe. In the 1920s, astronomer Edwin Hubble discovered that galaxies were moving away from each other. This proved that the universe was expanding and increasing in size. This discovery was developed by scientists into the Big Bang model. This is the theory suggesting the universe began from an extremely hot and dense point around 13.8 billion years ago. After an explosion, the universe was born and has been expanding to this day. Not stopping there, human understanding of the vast space beyond Earth continuously expanded. During this time, humanity achieved a series of milestones in its journey reaching out into the cosmos. At 22/28/34, on October 4, 1957, the R-7 rocket was launched at the Baikonur Cosmodrome in Kazakhstan, carrying the Sputnik 1 satellite, shaped like an aluminum sphere, into space. This was the very first time a human-made satellite flew into space. 34.5 seconds after separating from the rocket, the satellite began emitting beep-beep signals audible from tracking stations on Earth. Sputnik 1 entered orbit, reaching an altitude of 947 kilometers, carrying humanity's desire to conquer the cosmos. This sphere, 58 centimeters in diameter and weighing 83 kilograms, orbited the Earth 1,440 times, traveling a total distance of 60 million kilometers over 92 days. This marked the beginning of humanity's era of space conquest. Just 4 years after Sputnik 1 flew into space, the Vostok spacecraft, carrying astronaut Yuri Gagarin, launched from the pad at the Baikonur Cosmodrome in Kazakhstan. 10 minutes later, the ship entered orbit at a speed of 29,000 kilometers per hour, reaching a maximum altitude of 327 kilometers. Gagarin became the first person to see our shared home from outer space. After completing the journey orbiting the Earth in 108 minutes, astronaut Gagarin and his descent module landed safely via parachute in a field in the Saratov region. The first spaceflight to take humans into space was a success, becoming a source of pride and the greatest achievement of the Soviet Union during the Cold War and the space race. The Soviet Union's rival, the United States, refused to surrender in the face of these recorded achievements. The Americans retaliated with plans for an even bolder and more challenging event, becoming the first nation to conquer the moon. On July 16, 1969, the Saturn V rocket carried the Apollo 11 spacecraft and 3 American astronauts, Neil Armstrong, Michael Collins, and Buzz Aldrin, away from Earth. After more than 3 days of orbiting, on July 20, 1969, Apollo 11 officially became the first crewed spacecraft to approach the moon. Armstrong was the first person to set foot on the surface of Earth's satellite. That's one small step for a man, one giant leap for mankind. This massive achievement could not stop us on our journey to conquer space. On August 10, 1975, the Viking program was officially launched by the U.S. space agency NASA. Two spacecraft, Viking 1 and Viking 2, took on the mission of landing on the red planet, Mars. This was one of NASA's costliest yet highly successful events. Throughout their life cycle, the Viking spacecraft gathered crucial information about Mars, greatly aiding the study of the planet considered most similar to Earth in the solar system. Notably, the collected data revealed traces of massive water flows spanning thousands of kilometers, creating valleys and deep grooves carved into the bedrock. To serve the process of space research and exploration, astronomical equipment was heavily upgraded and refined. This was considered one of the biggest leaps of the 20th century. Launched in 1990, Hubble changed the way we observe the universe. Observing celestial bodies without atmospheric interference from Earth allowed Hubble to provide sharper, more detailed images of galaxies, stars, planets, and other astronomical phenomena. The Space Telescope helped confirm many cosmological theories and provided strong evidence for the expansion of the universe. Besides this, the radio telescope was also invented, ushering in a new era for astronomy. Humanity learned more about phenomena like supernova explosions, quasars, and pulsars. Many experts also realized that human understanding of space was still incredibly limited. Nations needed to cooperate to expand knowledge and lay the groundwork for many long-term future missions. Thus, the International Space Station, IS, was born. This is the shared home for many astronauts and space scientists from different countries, such as Russia, the US, Japan, and Canada. Together, they research various fields, such as the zero-gravity environment of space and exploration technologies. In short, the ISS is not just a marvel of technology and international cooperation. It is a step forward that lays the foundation for humanity's future plans. With the support of spacecraft and satellites, humans quickly understood and explored the planets within the solar system. And this was also the starting milestone for the journey to explore the edges of the solar system. On January 19, 2006, the New Horizons spacecraft was launched into space with the mission of exploring Pluto. It was launched with an enormous initial velocity and then utilized Jupiter's gravity to accelerate. This method is known as a gravity assist. In 2007, the New Horizons spacecraft approached Jupiter, gathering extensive image data of the planet and its moons while accelerating toward Pluto. The spacecraft took this opportunity to photograph and conduct scientific observations of Jupiter and its satellites. After accelerating at Jupiter, New Horizons continued its multi-year journey through deep space. On July 14, 2015, the New Horizons spacecraft reached its closest approach to Pluto at a distance of approximately 12,500 kilometers. This was the first time humans got a close-up look at this dwarf planet. After completing the mission to explore Pluto, NASA extended the New Horizons mission to study the Kuiper belt, an outer region of the solar system containing many icy bodies and serving as the birthplace of comets. By 2019, the spacecraft approached the object, 2014 MU-69, also known as Arrokoth, setting the record for the farthest object ever explored by a spacecraft. To this day, humanity has made many major leaps in the exploration and study of outer space. Numerous missions have been launched, and many successes have been reaped. But space exploration stands before a period of robust development with many ambitious plans. From setting foot on Mars to observing exoplanets beyond our solar system, humanity is inching closer to a deeper understanding of the universe and our place within it. These plans might seem vague and difficult to execute, but you and I have witnessed them slowly being fulfilled. Certainly, the coming decades promise to be a golden era of space exploration. with ambitious missions, advanced technologies, and discoveries that could completely alter our view of the cosmos. From early observations of the sky and stars, humans have gradually conquered the vast universe. The achievements we have attained are the clearest testament to humanity's intellect and boundless desire for exploration. Every historical period, with or without supporting tools, contributed valuable understanding to the grand picture of the universe. Today, with planetary exploration missions and space telescopes, we are closer than ever to uncovering the origins of the universe and the possibility of life existing beyond Earth. There will undoubtedly be many difficulties and challenges, but they still cannot stop humanity from continuing to explore. Now or in the future, humanity's space conquest will not stop, as there are still so many mysteries we have yet to discover. With the continuous advancement of science and technology, it is certain that future generations will carry on this great journey, expanding our vision to new horizons of the immense universe.